The following is a presentation of the Six Arrows Radio Network.
Today on the Workbench, ham radio for makers. The conversation with Kenneth Finnegan, W6KWF, and Mark Smith, KR6ZY. Stay tuned. Welcome to the Workbench. I'm your host, George, KJ6VU.
And I'm Jeremy, KF7IJZ.
This episode of the Workbench is brought to you by Elecraft, makers of high-performance radios, amplifiers, and other great station accessories. Check them out at www.elecraft.com. And by Autodesk, the makers of Eagle PCB design tools, the software we use to design all of our Workbench build projects. For more info and your free copy of Eagle, go to www.autodesk.com/Eagle today.
Welcome back to the Ham Radio 360 Workbench podcast, your bi-weekly deep dive on technical and maker topics of interest to the radio amateur. This week, we are joined by two special guests. First of all, I'd like to welcome in somebody who is new to the Workbench, but not new to Ham Radio 360. We have Kenneth Finnegan, W6KWF. Kenneth, how are you?
I'm doing great. Thanks for having me, guys.
And also, we have somebody else who has never been on Ham Radio 360, but has been on the Workbench, and we have brought back Mark Smith, KR6ZY. Mark, how are you?
I'm doing great, Jeremy. Thanks for having me back, and it's great to meet George. Meet George first.
I was about to say, somewhere in there is George. George, are you there?
I'm here. Hey, Jeremy, and nice to talk to you guys, both Mark and Kenneth.
This week, the show is going to be a little bit inverted from where it normally has been, because we've always made a strong effort to try to take, modern makery type topics and apply them to amateur radio. But this week, we're going to be taking kind of an inverted look, and that's, what does being a ham get you as a maker? What does it make available to you? What does it open up to you? What does it expose to you? Why is it something that somebody who may not be an amateur today or may not be familiar with ham radio today, but are interested in tinkering with microcontrollers and single board computers and other quote unquote makery things, why might they be interested in getting their ham license? And so before we jump into that topic, Kenneth, why don't you give us just a little bit of your background as both an amateur and kind of a tinkerer?
Sure. So, just kind of to get the intro on my life story as an amateur radio operator, I first got licensed in about 2008. At that point, I was a freshman at UC Davis in mechanical engineering, and my father actually had always wanted to get his amateur radio license, and he decided the easiest way to do it was to live vicariously through me. And so for Christmas, I got the license manual and the study guide from the ARRL, got licensed, and then got into amateur radio, right? So I eventually upgraded to general and extra. I got involved with Field Day in the Bay Area with our plethora of amateur radio clubs in the area. And it was actually at one of the Field Day events that I ran into a whole bunch of the Cal Poly Amateur Radio Association, Cal Poly Amateur Radio Club members, and they actually talked me into going down to Cal Poly for my master's degree, right? Because the Cal Poly has an incredibly good active amateur radio club for being a college. And so I went down there, lasted 2 weeks as a mechanical engineer, and then promptly switched over to electrical. And so it was 2 weeks. I met once with my advisor, and he did not like this whole mixed hybrid, doing electronics and programming sort of things that I do. And so I switched to electrical engineering. Right. And so this was me going into the department head's office and sitting down for 15 minutes. And I pulled up my website and my projects and all the things on my workbench. I brought them in and showed them to him. And he said, "Great. You want to teach classes too?" And so I became an electrical engineer. During my master's degree, for amateur radio, I got real involved with emergency communications, repeater systems, so electrical, like solar DC systems, all this sort of fun stuff, and packet radio, right? So I actually ended up doing my master's thesis on APRS. After I graduated from Cal Poly, I went off as a test engineer at a solar cell startup for a year and a half. And after that, I've moved on in the Silicon Valley way of only lasting a company for 18 months. I'm now at a Lam Research, where I'm a systems electrical engineer working on plasma wafer etch equipment. So that's my day job. In my spare time on my workbench, I work on UHF repeater systems. I run a little repeater rental business between my friends and I for Land Mobile, like both Part 97 and Part 90. We do a little bit of business there. And then I do all sorts of packet radio stuff and amateur, for APRS and software and all sorts of fun there.
Well, cool. And Mark, give us a little bit of your background as both a ham and a tinkerer.
So, well, if we're going to go back as far as Kenneth did, yeah, sure. I grew up in a very nerdy family. My dad worked for IBM for 32 years. My mom was a network engineer at the local high school. I was pretty much doomed to be a geek from the onset. I've been into computers from a very early age, mostly PCs, because that's what my dad would bring home from work. And that got me into a lot of kind of working on the hardware of the PCs, assembling my own systems. Actually, like while I was in high school, I was doing ISA level GPIO interfaces with my PCs to control robotic arms and that kind of stuff. So I've been doing, and that was in the early 90s. I got my ham license it was either 91 or 92. I don't remember which year it was, but it was during my junior year in high school. I remember that. And I was working at an electronics junk store up in Mountain View that George may remember called Haltech.
Yes.
Not Halted, not HSC, but Haltech.
Oh, yes. I know the place well. It was a block behind my favorite Mexican restaurant, actually.
Oh, yeah.
Which is no longer there.
Yeah, no, I can't remember the name of that restaurant, but we used to eat there all the time. So I worked at Haltech for several years, and my manager there, a guy named Russ, for the life of me, I cannot remember his call sign. I've been trying to look him up for years, but he was a ham, and he kind of talked me into getting my ham license. So I went up there, got my ham license when I was like 16 years old, maybe 17. And I used it a lot while I was in high school. I did a lot of 3-meter transmissions, which is not exactly Part 97, but I did that. I used that knowledge for that. And then I went off to college, and I found the Amateur Radio Club, the same one that Kenneth was talking about, although I was there about 10 years before he was, at Cal Poly, W6BHZ. And so I was a very active member of W6BHZ from 93 until 99 when I graduated. Yes, it took me 6.5 years to get my bachelor's degree. But I enjoyed every minute of it. So I was really, really active during school. I volunteered for a lot of the same events that Kenneth did. The Wildflower Triathlon is the big one. Since then, I kind of fell out of it a little bit, back into it a little bit, back and forth. But the last several years, I have really been using ham radio as kind of an excuse to get out and build things. And so I think that's going to feed really nicely into today's topic.
Before we get into the big topic of the evening, as is customary here on the Workbench, let me ask you guys, Mark, what's on your workbench?
Oh my gosh. So I just bought a new car a couple of months ago, and it does not have any radio gear in it. And I'm trying, my old car was a used car, and I didn't mind drilling holes in it. But my new car is a brand new car, and I'm kind of loath to drill holes in it. And I know I'm going to lose some ham nerd cred there. But I really just kind of want to keep it pristine. But that doesn't mean I don't want to modify it. And so I've been doing a lot of projects to be able to mount all of my radio gear the way I want it into my car without doing any permanent modifications. That involves making custom metal brackets, 3D printing custom forms for mounting like display heads to and speakers and all that stuff. So I've been doing an awful lot of that. Electrically, I have some weird problems with trying to get power to it. In my old car, the battery was in the back of the car where the radios were, so the power cords were nice and short. In the current car, the battery is in the front, and all of the gear is going to be in the back, so I don't want to run like 8-gauge power cords just because it's big and heavy and expensive and a pain in the butt. So I'm going to do some fun stuff with a local battery in the back and have the car just charge it at low current and some fun things like that. I also want to minimize the number of cables I have to run from the back to the front where the control heads are. So I am mixing multiple different speaker levels coming out of radios, mixing it into a single signal, reamplifying it, and then sending it up the front. So it's all mixed into a single speaker rather than having to have one speaker for every radio. So that's been consuming pretty much all of my project time over the last few weeks.
Well, cool. I mean, that's a really awesome practical application of a lot of the, the skills and experience you have. Kenneth, what about you? What's been on your workbench?
Well, the first question is which workbench is. I definitely have been reveling in being a bachelor and went and got myself a 2-bedroom apartment. So I actually have a second bedroom that's entirely dedicated to desks and industrial shelving for my stuff. But if we start at the right side of the room and work our way around, on the main electronics bench, I've actually got the K4 CDN digipeater, right? Because Kayla and I have been talking about APERs for a couple months now, and so we've bought all the parts, and I finally have all the materials. I'm trying to put it together so that we can put up a digipeater at the CDN repeater, and so he'll have a RF and iGate there as well. So it's going to be a Raspberry Pi with his TinyTrack 4 TNC and then a Motorola CDN 750 VHF radio, right, which has all sorts of problems with the Raspberry Pis because they're single board computers that tends to flake out a bunch, which George has probably felt some of that pain with the flakiness of single board computers. And so it's been a lot of kind of hardening that and getting all the cables built and getting the software configured for Kale so he doesn't need to learn Unix from the ground up. So that's kind of been right. That's the first project. I would say on my second electronics bench, the other thing I've been playing with is
because every real ham needs two.
Well, I mean, why the man with the most junk wins, right? So
I can help you with that.
Yeah, you've been trying. So on the second bench, I'd say that my second tier project has been I've been playing around with Strata 1 NTP. Is the Raspberry Pi is particularly well suited to feeding GPS signals into it and synchronizing time servers. And so if you're interested in playing around with Strata 1 NTP servers, NTP Sec is this branch of NTP Classic. They've been working on hardening NTP, and they've got a great guides set up for playing around with. They use Raspberry Pis for their whole development farm. And so if you want to set up NTP and play with it on Raspberry Pis, they've got some great tutorials on NTP Sec.
Well, that's cool. Actually, it's funny because one of the things that I've got my eye on at Dayton this year is airspy.us should be there, and they have started selling. Have you ever heard of Leo Bodnar or Bodnar?
No.
So he's a ham, I think, out of the UK who worked with a company to start manufacturing very high quality, or at least ham high quality, basically GPS disciplined oscillators for accurate timekeeping. AirSpy sells them because you can use them to synchronize your SDR receivers to them in case you're doing stuff that requires that. But he has a new product out that is basically a Stratum 1 NTP server as an appliance, directly built into the box. Plus, it still gives you your high quality signal sources out. So it's actually one of the things I'm looking forward to hopefully seeing in person. I don't know why, but accurate time is it's super geeky, but it just makes me feel good.
Oh, yeah, for sure. Right. And I've got a rubidium frequency reference that I built several years ago and put on my blog.
As you do.
Right. Because, you got to have a 10 megahertz base for all of your other test equipment. And it's really kind of silly that we're playing around with all this on Raspberry Pis, because what is the first thing that the Raspberry Pi hits as it heads outwards to the world is a USB bus server. There's that problem, but between the Raspberry Pi and the rest of the world is a USB-based fast Ethernet NIC. So all of these gains that that you can play around with on the Raspberry Pi, like temperature compensating and stuff, all dwarfed by the jitter of a USB bus between it and the world. So it's one of these things where you just got to put the Raspberry Pi out on the table and measure how big it is, sort of thing. So
all right, so let me ask you a question though, kind of unrelated to this, since we're talking about your workbenches, and maybe you were going to get to the third workbench. You've been tweeting a lot in the last week or so about remote temperature sensing.
Yeah, so this has been something have been working on with my dad. Of course, the apple fell not at all very far from the tree here, and so something that my dad and I have always really wanted to do for a long time is room resolution temperature in a house, right? So kind of your wall thermostat sort of data logging, but at the room resolution. And so it's one of these things that kind of I finally this week decided, dang it, I've been heckling Mark on his YouTube channel laying out PCBs for months now, but I haven't actually laid out any PCBs myself in a couple years. And so I finally downloaded KiCad and have been laying out this little board that is a ESP8266, which, if you're not familiar with this, it's an awesome like couple dollars IC that has Wi-Fi, a whole IP stack, and then a couple GPIO pins. And so it's an ESP8266 microcontroller, and then I'm using one pin out of it to speak the Dallas one-wire bus to DS18B20 temperature sensors. And so the concept here is that in one room I could have just a USB wall wart go onto this little board that I've been laying out that has a ESP8266 and one of these temperature sensors. And then it's got 8 P8C connectors, which everyone calls RJ45, has an RJ45 connector on it that you can then chain just off the shelf Ethernet cables room to room. And then I'm gonna make little daughter boards so that you can have more of these Dallas one wire sensors in each room. And then it'll push, then the ESP8266 will take all this temperature readings on like a 5 or 10 minute resolution and then push these to a Raspberry Pi that'll be pulling and logging it over like SNMP or something, right? Some network protocol, probably MQTT, which is another great Internet of Things protocol, right? And it's one of these things where having it just be one ESP8266 plus these one wire chips, like I can get the BOM cost for this thing relatively cheap so that it's not $100 per node or something. And so that's something that I've actually been playing around with my dad to finally get back into board layout and feel all the pain that is KiCad. So
I would like to point out that he's been doing this one board, and while going through the process and figuring out how to do it correctly, he will periodically poke me in Twitter. Mark, this is what you've been doing wrong. This is the way to do it right. Like 3 or 4 times he's poked me. It's like, stop doing it wrong. Go do it this way instead.
Right. And it's like, I did feel a little bad though, because I've been giving him a hard time on it because Mark has this great, Smitty works on things streaming, YouTube channel. And I give him all this hard time for months now for while he's been laying stuff out, but I don't actually lay out boards at work. I have designers that work for me. So all of my schematics and stuff, I just doodle them on a napkin and hand them to other people and make them deal with all the quirks of CAD layout, which invariably, regardless of whether you use Eagle or KiCad or OrCAD or whatever layout system you use, there's always awful, terrible pain points that seem like deal breakers. They're all just not good. So
they've all got their quirks, advantages and disadvantages. Yeah. No, I like having the peanut gallery. So no, you're welcome to heckle me anytime.
Oh yeah, for sure.
Hey, we learn through heckling.
Exactly.
As in we learn who our friends and our enemies are.
That's right. If someone's comfortable enough to heckle you, then they're a friend.
Yeah.
George, what about you? What have you got on the workbench? Actually, we've seen some pictures of what you've had on the workbench here lately.
Yes, you have. So my big focus has been getting ready for Dayton, and we want to bring some of the build project boards to Dayton. So we've got, at this point now, 5 different project boards besides the antenna analyzer. We have the power monitor LVD thing. We have the little power strip. We have the QRP dummy load and the QRP dummy load with an Arduino. So this last week has been finding time to just build a few of these things and figure out if they work or not, and get ready to bring that stuff to Dayton. So that's kind of been at the top of my list. So that's keeping me pretty busy. The other thing that I've been tinkering with that's new is kind of along the lines of what Kenneth was talking about. I've got some projects where I've been doing wireless connectivity between the devices using XB radios, which work fabulously, except they're very expensive. So they're about $19 to about $35 a piece, and I've been in the hunt for something cheaper, and I didn't really want to use Wi-Fi for this for a variety of reasons, and so I finally found this Nordic Semiconductor chip, which everybody seems to know about but me, called a NRF24L01, which is a little 2.4 gigahertz data radio.
Oh, yeah.
And I'd seen them, but I never really looked closely at them. And it turns out there's all kinds of libraries for Arduino and Raspberry Pi. And when you actually go to buy some of this stuff, they're incredibly cheap. So you can get the low power ones for like $1 or $2, and you can get the high power ones for like $4. And so they're really, really cheap. And if they're any good at all, then it would be a great replacement for some of the projects I'm working on. So I finally got a pair of these radios to talk to each other after a bunch of dorking around. So it turns out there's a few things you have to look out for, and I finally got it set up and it's working. So that's great. So that's on the positive side.
So question for you real quick.
Yeah.
Because when we were talking about, in the episode, we talked about the wireless communication options on how do you talk to sensors or different microcontrollers. One of the boards we did look at was NRF. So is NRF basically the model number for Nordic Semiconductor stuff?
Yeah. So Nordic, like any semiconductor company, has a whole catalog of different parts they make. And this is just one particular component, which is this all-in-one data transceiver chip, which is about, oh gosh, not even a quarter of an inch on a side. It's very tiny. It uses the SPI bus to talk to the computer or microcontroller. And at the other end, you put like 2 coils and an antenna. But you can buy the whole thing on an itty-bitty circuit board for $1 or $2.
They're about the same size as the ESP8266.
Yes. They're very, very similar. Except that I don't think you can really program this as a microcontroller.
No, you can't.
Like you can on the ESP. So you have to marry this Nordic chip with a micro, like with an Arduino, and then you can do whatever you want.
I guess I'm thinking of their higher end stuff, because I've talked to Nordic before, and they've got like the 8502 line, because they definitely took this same radio transceiver IP. Because one of the big real appealing things of the 24L01 is that if you only need like 16 or 32 byte packets, they've got a whole packet engine in them with like point to point and star topology routing and everything. And they took that IP and put it in higher level microcontrollers. So if you like that radio, they've got that same radio in like actual. I don't know if it's not an 8502, unlike the part number, but they've got it. I think it's got like an ARM core in it, something. So you can get Nordic stuff with intelligence in it.
I'm not so interested in that chip per se. What I'm really more interested in is that you can buy them for $1.
Right.
So if they took their higher end programmable ARM-based thing and you could buy it for $5, then that would be awesome. But I haven't seen that. So what I have seen from various sources on eBay and Banggood and all these other low cost places is the 1 milliwatt version of the radio is like $1 to $2, and with a little like circuit board antenna. And then somebody makes a slightly bigger one. It's about twice the size. It has the exact same chip on it. Plus it has an additional chip that's an RF front end. So the RF front end is an LNA for the receiver and a PA on the transmitter. So that thing runs 100 milliwatts. And that board is only like $4 if you buy like 3 or 4 at a time. So that's really, really reasonable. So then the question is, how good's the library? And like, for instance, in the DigiMesh XB stuff from Digi International, they have a meshing stack that just works out of the box, and it's very good. And Nordic didn't really make a stack, like a meshing stack for this chip. So other people, hobbyists, have made the initial like star topology stack, and there is a mesh version of that stack, which I haven't played with yet. So I don't know if it's good or not. So, some guy like one of us made it. So who knows if it's, tested or not. But anyway, the point behind all that is that one of the biggest costs of making a wirelessly connected thing is the wireless part, if you go out and buy a really good part. So this seems like a very cost-effective alternative. So that's what's on my bench. And actually, 2 projects you guys mentioned, I took a note that we might want to come back to. So Mark, your speaker amp mixer thing, is something that I actually built something that does that. And I don't know how far down the path you are building it, but that's something we can compare notes on. So I built a shack accessory. Have you built that yet?
I have first version of it, and it's got a bunch of problems that I need to go figure out, and I'm going to rev it.
Okay, so I mean, if you're interested, I've got an assembled board. I could give you one if you want to play with it. So it takes speaker level inputs, and the transformer isolate, and it all mixes down to a 10-watt PA that goes to a speaker. So so that's something we could talk about later. And I've also been messing with my Raspberry Pi Zero Ws and trying to figure out what you could do with it, and so marrying that, which is $10, with one of these little data radios, which is $3 or $4. Man, there's a lot of stuff you can do. So I really appreciate, Kenneth, your comment about like those ESP chips, because you can get the price down so low that you really can make a lot of interesting projects with a lot of nodes in it for not much money. So that's very cool. And I think the Raspberry Pi is cheap enough, but the Zero is even cheaper. So it's pretty interesting.
Yeah, and one source of frustration for me for the ESP chips that has just been driving me nuts is this has been always kind of my dream project of running a multi-drop sensor node network using like RS-485 or something room to room. But the problem is when every single one of your boards needs to have both whatever your sensor is plus a microcontroller plus a RS-485 transceiver to go into this twisted pair network that I dreamed to set up. It's never justified versus just putting another 8266 on every single board and just running power to each one of them. And so it's one of those things that I've wanted to make it work, and it just doesn't, because these ESPs are so cheap. And it's just like the switch mode power supply, gum stick things that, like, I know that Mark has used these, where like you can for like a few dollars get one of these switch mode power supply voltage regulators. And it just undercuts me ever bothering to lay out a voltage regulator on any of my projects, because I may as well just buy the $2 module, which assembled and finished is cheaper than the BOM cost of it, and just drop that into my project as is. So it's that has been driving me nuts, but it's definitely a huge advantage to this eBay access we have.
That's a really interesting topic, and we talked about that in a previous episode, where you can get so many boards with parts on it cheaper than the price of the parts.
Yeah,
it's just kind of mind blowing. It's like when I look at this Nordic board for like the fancy one for $4 a piece, and it's got 2 chips and a dozen discretes and an SMA connector, and I think if you price it all out, I'm sure that's $8 or $9 of parts, plus the circuit board assembly. I mean, you can't make it. You cannot make it for the price which you can buy for. So one direction I think a lot of these projects go in is we wind up laying out circuit boards that are essentially motherboards to take off the shelf breakout boards, and the motherboard is essentially just interconnect and a jack for power.
Yeah.
Which is okay. I'm not complaining. I mean, would it be great if these boards were really cheap? Well, there you go. Now they are.
Exactly.
Yeah, except that every 9 months they show up and that it's slightly different, right? Is they don't have much very good change control on them.
Well, so actually that is the big risk, is that like when I looked at these Nordic semi data radios, I'm thinking, oh my gosh, $2 to $4, this is fantastic. And if you build a project that other people will build on, and you plan to use this for 5 years, what are the odds that these same boards are going to be available in 5 years? So it's sort of, unless you're doing a one-off project, you almost have to buy like 100.
Yeah, you have to do your lifetime buy from the one buyer that you design it off of. Yeah,
exactly.
On that subject, I've actually found that the modules that you can buy from China that are direct copies of a more expensive module made by a company in the US. For example, like the ESPs that we like that have 2 GPIOs on them, the ESP-01, that is a product that is made by Espressif. I think it's actually them who makes it, or it's somebody in the US. And then the Chinese company is just like, we can do that for a heck of a lot cheaper. And they all come out. They've got the same layout. They've got the same artwork. They've got the same pinout. Everything about them is the same. I've found that those kinds of copies tend to be available consistently and for longer, because there is a definitive standard that they are all working toward. Whereas if it's a new thing that China has come up with on their own, kind of like the switching modules we were talking about, those tend to be just a little tiny bit different from maker to maker, whichever fab house it is in China that's cranking those out. So yeah, it depends on what kind of module you're looking at.
So I think this whole notion of obsolescence is an interesting one in the hobbyist community because, why would that be an issue? You're going to go build one of something, but a lot of times you build one and then your friend wants to build one, and then because of the web and you could self-publish, and then you get people that say, hey, Mark, can I build the thing that you built? And like, you can, except you can't get the parts.
So I think though that's one of those areas where, if you take somebody just starting out who stopped at Micro Center or Fry's and they picked up, like an Arduino Uno, right? That board is what, 5-6 years old now?
Oh, more than the Uno?
Like 10 years old.
Well, I mean, the Uno's like 10. There's several revs on it, but the point is that in that, when you're looking at like the commercialization towards the hobbyist, there are decisions that the Raspberry Pi Foundation made in 2012 and before that we're going to be stuck with for a long time, because the hobbyist market kind of needs that stuff. As you start moving outside of the hobbyist market, and these ESP chips are a great example. Adafruit does sell them on a few boards, but when you get to the level that you guys are operating at, where you're actually just buying the chips and adding them on your own boards or having a fab house do it, you're starting to get into those commercial waters where you don't have some of those protections and those lack of planned obsolescence built in.
Well, I think that points you to choosing things that are likely to have a long shelf life. So when you, for example, looking at something like the Raspberry Pi, today there's probably, I've seen at least a dozen companies out of China that make something that's very similar to a Raspberry Pi that has at least a couple of features that are on the surface better specs than the Raspberry Pi for the same or less money. And yet I'm personally not motivated to go buy those things, because either the drivers will have some problem, or they're going to not make it in 6 months, or there's just something that's kind of hard to plan around it. Whereas I know at this point, Raspberry Pi and Arduino for the most part has won, in the sense that they are the ubiquitous standard form factors that are going to outlive their, the original intent. So,
well, I would argue argue in favor of your point. That's by and large due to the attention and effort that was put into basically documentation, education resources, and community. And in fact, this is a perfect segue. Somebody asked me what's on my bench.
Hey, Jeremy.
What's on your bench?
What's on your bench?
All three at once. Let's try that again. 1, 2, 3. Hey, Jeremy.
What's on your bench?
It was better when it wasn't planned. Anyway.
Oh, sorry.
I got my 3D printer this weekend, the Ultibots D300 SV. I'm working on that. My fingers are very sore from squeezing a lot of metal parts. But so that aside, I came across the new Asus Tinkerboard. Speaking of Raspberry Pi alternatives, you guys heard of this thing?
Yeah,
I have not.
So we all know who Asus is. They are one of the world's largest manufacturers of computers and motherboards and pretty much everything you need in the DIY PC arena. They decided that they wanted to get into this maker movement. They think it's a thing. They think it's going to be around for a while. So what they did is they basically perfectly cloned the physical size of a Raspberry Pi 3. The ports are in the exact same place. The onboard camera connector and display connector in the exact same place. Like the physical interactions, like the screw holes, everything, the GPIO perfectly mimic the Raspberry Pi 3. Now what they've done.
Okay, hold on. Before you go on, let's be very clear here. Not only did they perfectly mimic the Raspberry Pi, they put a beautiful custom colored header on it. So if you ever want to see how to do an amazing hobbyist product, the header on this board is beautiful because they color code the pins on the actual plastic extrusion of the pins. Sorry, go ahead.
No, that's true. They do. So that's first of all, physically they're identical. And what that means is that every hat that I've ever bought for a Raspberry Pi, the Pi Top Seed that I have, every accessory that has ever been specific to those 40 GPIO pins is accessible right out of the box. So boom, they didn't have to invent their own standard. They didn't have to get people to try to build stuff. They were already coming into the market and they have access to all this hardware. So that's fine. The real key differentiators is the Raspberry Pi 3 is an ARM A53, if I remember correctly, processor, quad-core, 1.2 gigahertz. That's fine. It's 64-bit capable, but the software is only 32-bit, and the Pi Foundation says they have no reason to want to actually go and write 64-bit software. 1 gig of RAM, cool. The Tinker board is an ARM A17 32-bit processor at 1.8 gigahertz quad-core. Also 2 gigs of RAM on board, and the GPU on the Tinker board is a quad-core ARM Mali at 600 megahertz, which basically what that means for you is 4K for the people who are going to buy this and use it for a home theater PC. 4K. So I got the thing home. I downloaded the firmware image that they have, which is basically there is a distribution out there in somewhere probably in the Far East called Linaroo. Kenneth, have you ever heard of Linaroo before?
I think so, but I've tried to stay away from weird distros in the last few years. Life is too short to play with one-off distros.
Like I really do feel like it is like a Chinese distro, but it's based on Debian. I wasn't sure what to expect because I know, George, you talk about all these other knockoffs. There are things like the Orange Pi, the Banana Pi, the Apple Pi, the Odroid C series, and the U series. But I was kind of pleasantly surprised. I mean, I got it home. Most people probably know that I run a farm of Raspberry Pi 2s and 3s, running a project in support of the project is called Einstein at Home. It uses Boink, which is it's distributed computing software developed actually at from UC Berkeley originally. And my Raspberry Pis sit and process data from Arecibo radio telescope all day long, 24/7, looking for signs of binary pulsars. So I was surprised that I get the thing, put the card image on it, do an apt-get update upgrade, and come back in. The GUI's working. A little bit of weirdness around getting the Wi-Fi working, but nothing really that complicated. I did an apt-get install Boink, then attached to Einstein at Home, and I was up and running, which I couldn't believe the experience was that good out of the box. Now, what we're missing, I can't find a community. Kenneth, have you found a community?
So I haven't. So it's funny that you bring up the Tinker board because I was actually joking about it this week on Twitter. You've left out the one giant strike against the Tinker board. It's more than $35.
Yeah. Well, yeah. Well, see, yes, it's $60, and the thing is, their argument is it's twice as performant as a Raspberry Pi 3. That's their argument. And
I think this, I think that these things just sort of boil down to what are you going to do with it? So if at the end of the day you said, I want something, the form factor of a Raspberry Pi with the maximum performance for $20, this is a swinging deal. But if you said, I want the ultimate predictability and behavior of what everybody else has at a lower price, than a traditional Pi still sort of makes sense. But the one feature of this board, having only looked at it now for the first time, there's one feature I can see right away that I do really, really like on it.
Besides the sexy header?
It's got an analog audio jack.
Well, the Pi does too, but it sucks. This one's got a 192/24
it's
HD
a pretty
audio.
legit HD. Well,
yeah.
Let's not use that. There's no such thing as HD audio.
Well,
it's a 192. I mean, it's got a much better EDC and DAC on it.
Yeah.
So in my mind, though, at the end of the day, that for a hobbyist, it depends on what you're going to do with something like this. I think in your case, Jeremy, where you had a specific application in mind, and if you do the install and it goes great, then everything is fine, and that's awesome. And it's probably mostly the case. The one thing that I've been very, very pleasantly surprised about with the Raspberry world is that if you need to look up anything about programming on the software side, that there's such a huge Raspbian user base that every stupid question I can come up with, somebody else has already asked it.
So there are several stupid answers to it.
I mean,
Yes.
and that goes back specifically to the point about community.
Yes, exactly.
The forums and the investing in the documentation and the education. The Tinkerboard doesn't have any of that. Like,
let's be very fair for ASUS though. This board has officially been out for like 3 or 4 days.
That's fine, but Raspberry Pi launched with some of this stuff.
Right. And this has been very strange for the Tinkerboard because everyone has known about it and everyone has known exactly what it looked like now for like 3 or 4 months. But
of course
ASUS,
they do. It looks like a pie.
Right. Well, yeah, it does. But like the images have leaked on these things so early on. And then like ASUS was refusing to like even admit they were working on it until like finally this week they make this big announcement. Hey, here's our big Tinkerboard. And everyone's like, yeah, we've already seen it and know all the specs on it. But I mean, it is a very cool board.
Now, here's just something to pass along. From a power requirements perspective, running a Pi 3 full tilt, all 4 cores completely pegged at 1.2 gig. You're running, I can't remember now. That's okay. I have a video all about building clusters out of them. So
I was actually, I'm interested in knowing these numbers because that was going to be one of my questions about the Tinker versus the Pi.
So this is something that I have an inline USB power meter. I need to throw it in there. If I remember correctly, you're only like full tilt. You're drawing like 0.8 amps on the Pi 3. No, that's no other peripherals not being connected. Like I run all of mine headless. So I mean, there's no peripherals. There's no nothing. I need to get the power measurements for this, but here's a performance thing for you, for any of you math geeks. So the Einstein at Home application is basically using fast Fourier transforms to do the analysis. The application that you get from Einstein at Home has been optimized for ARM platforms generically and not specifically the Raspberry Pi 3. One work unit on my Pi 3 would take about 11 and a half hours to return. A Pi 2 would take about a day. So when I ran just out of the box the default client on the Tinkerboard, they were coming back in about 5 hours. So already in my mind, from a raw computing power perspective, I'm like, wow, okay, so that slightly less than twice the price is actually netting performance that exceed, it's faster than the cost increase. Maybe it's worthwhile. Then I came across somebody who had super optimized the Einstein at Home client for Raspberry Pi 3, and I got that up and running on one of my Raspberry Pi 3s, and it comes back in 5 hours. What that tells me is if I were to actually sit down and try to do the optimization for the client, like by compiling stuff specifically for the CPU, generating an FFT wisdom file for the FFT software that they use, would I get it down to 2.5? And from a raw performance perspective, I can't say that it's twice as good yet based on the things that I use it for. Now, what I do think it's good for is I think it might be an awesome candidate if you're a ham that wants to lug a computer into the field. Especially because 2 gigs of RAM gives you a lot more options for GUI apps. And having more processing power gives you more options for what you're running simultaneously, especially like on the SDR front. I mean, that's one of the areas from a ham perspective where I think this does start to get a little bit more exciting. But if the software is not there in the root OS distribution, and there aren't people who are going out and compiling packages for this thing, then it'll be a moot point.
Yeah. So let me tell you a little bit about the 2 different applications I have for Raspberry Pi small single board computers like this. One of them is as my network router at home. I'm a network engineer by trade, and so I cannot abide by like a little Linksys router for my home network. So I run a Raspberry Pi. I do VLANs, and I've got multiple access points around the house because I'm a nerd and it's what I do. But you had me on this Tinkerboard at gigabit Ethernet with dedicated I/O to the CPU instead of being a USB attached 100 megabit Ethernet. Nothing I do so far has really required faster than 100 megabit. And so it hasn't really been a problem so far, but the concept of being able to run a native gigabit Ethernet interface on my small board computers is intriguing to me. The second use case, one of the things I kind of left off the talking about the radio mounts I'm putting in my new car, is when I took a 2-week drive around the southwest part of the country from California out to Kansas and back last June, I installed a Raspberry Pi in my car with a USB webcam on the dashboard, and I just had it take a snapshot, a static photo every second. And when I got to my hotel room that night, I'd load them all onto my laptop and compiled together a time lapse. And those time lapses are now available on my YouTube channel. And that was just kind of a fun project that I did. And it got me thinking about the kinds of things that I can do if I have a computer in the car all the time. The two radios I'm installing, one is a D700, which can do APRS built in, and I don't really need to receive APRS while I'm driving around, so I'm not too worried about that. But the other one is an FT100, which is an old school Yaesu mobile HF rig. And my car is a Prius, otherwise known as a big rolling ball of QRM, because everything it does is pulse width modulated, and it just puts out so much noise. You can't do anything in HF while the car is turned on. But it is really good at drive somewhere, park on the side of the road, attach an HF antenna outside, and operate from there. And I like digital modes for a lot of different reasons. And I'm trying to think of ways to be able to rig up my FT100 to do digital modes. One of them is just running a USB cable from a USB serial adapter for the CAT controls and a USB sound interface for the audio in and out of the radio, and then run that USB cable up to the front of the car where I plug it into a laptop. So I just pull over on the side of the road, get my laptop out, plug the USB cable in, and now the radio is connected to my laptop. That's one option. The other option is to mount a Raspberry Pi in the back of the car with the radio and have it connected all the time, and then either do like a Bluetooth keyboard or turn the USB cable around and plug in a USB keyboard and trackball or trackpad and run like a small HDMI cable up to the front and find a way of mounting a small LCD screen somewhere in the front of my car. That one's more permanent and doesn't require other stuff to be brought into the car, but the laptop version is kind of less intrusive. So I'm still debating how I want to go on that. But the concept of having a computer, and this is the reason why I'm very interested in its power consumption, because I'm curious how much power it'll consume because while I'm running on battery, I'm always running on battery because my car's not turned on. How much power would it consume there? And then the sound interface was the other one that was interesting. If I can hook it up to the radio without having to use a USB sound interface, that would be very interesting to me as well.
One more thing to point out about the Tinkerboard that is interesting. So the hardware that's on there is there are Chromebooks that you can buy that have nearly the same hardware on them. You're paying about $200 for it. But of course, there's a screen and whatnot.
But I'm also not going to be able to install arbitrary software on my Chromebook.
Well, you can, but that's a separate topic.
I was going to admit that those you can get those Raspberry Pi like back of monitor brackets that goes from like Visa on the monitor, the standard monitor hole mounts to a Raspberry Pi. I think those brackets just got a lot more interesting for me because I think I might actually finally be willing to I would actually probably try using this as a desktop computer. Like not my primary one, but as a secondary desktop. This might actually finally be worth trying to fire up a web browser in. I mean, and that's the thing, right? One of the first things I tested was YouTube, because YouTube on Pi 3 is marginal. This, it actually worked. Wow. I mean, right. Granted, it says it's supposed to be able to do 4K video. I was doing 1024. Or sorry, 1080. HD, and it was okay. I mean, it wasn't perfect. I don't know how much of it was still the machine doing stuff on first boot up. The machine did run a lot faster. Like the GUI felt faster. Like the mouse didn't lag after I did the apt-get upgrade. But the other thing to point out that's interesting about this is that there's also a version of Android 6 available for this machine. I mean, there are a lot of cell phones also very similar hardware spec.
And I think that's actually kind of cool, especially with the convergence that in theory is going to happen any minute now between Android OS and Chrome OS. But anyway, so it's an interesting board. Like my initial thoughts is that for hams, it is enough of a performance bump over what you get out of a Pi 3 that it might actually not be a terrible secondary computer or field emergency computer. But the key is going to be the software. And we don't know what ASUS has planned for maintaining their distribution of what they call Tinker OS, which is again something based on something called Lineru. But it'll be interesting to see what happens. And Mark, I will measure power consumption and let you know.
Cool, thank you.
Yeah, and I guess one last thing I just noticed on it, and this actually is also very exciting. The Wi-Fi on it is via a UFL jumper. And so if you want something better than the chip antenna on the board, you just take the jumper off and you can plug in like a magnetic mount, 2.4 gig antenna. And so for your car PC, like you could have it so when you pull in your driveway, it would be able to associate with your home Wi-Fi.
Yeah, I mean, and actually to that point, there are no shortcuts really taken on this board as far as how it's put together. I mean, to the point that you made earlier about when we were talking about time, the Raspberry Pi, as you mentioned, the Ethernet controller on a Raspberry Pi is a USB Ethernet controller. I have run into issues before where I was using Pi Zeros as Linux USB gadgets, where I was having them run as individual compute modules and then just plugging them USB. And when I added the fifth one connected to a Pi 3, like when I was SSHing in, like you would hit a key, get up and go get a cup of coffee and come back. Then you could hit the second key because the whole bus just couldn't handle the traffic.
Yeah. Yep.
So, yeah. Now we're
done talking about what's on our workbench.
I was going to say, we've done a great job of vacillating back and forth between this electronics and tinkering hobby, and then we would immediately jump back into amateur radio and then jump back out. I think that's a perfect segue to get into our main topic tonight, which is what does being a ham get me as a maker? And after this break, we'll get started.
Elecraft is one of my top picks for high-performance HF radios. They make fantastic base station style radios, amplifiers, pan adapters, and other station accessories. They're also the designers of the KX3 and KX2, the ultimate portable HF radios. If you're thinking about SOTA, portable operating, or travel, you really need to be looking at Elecraft. Elecraft has some of the best designs in the industry, compact, high-performance, feature-rich designs. You're really going to love them. And Kale just got his KX2. So be checking out the Ham Radio 360 podcast and also the Facebook page and see what he's doing with his KX2 radio. The KX2 is my personal favorite for going portable. It's ultra small, 80 through 10 meters, sideband CW and data modes, and the thing runs 10 watts on the internal batteries. You'll love it. Check it out at elecraft.com.
So as we said, today we're going to be discussing what does being a ham get you as a maker? And to me, this is an interesting topic because if I look at my early days as a Ute and my interest in electronics and tinkering around, I didn't have the resources or access to education or tools or guidance in a manner that suited my learning style. And so I would have my entire life been interested in electronics and have always been stymied. And with the advent of things like Arduino and some of these other, initiatives and products that are out there designed to get people access to modern microcontrollers and all of the resources out there about analog electronics, I myself have started tinkering, though not to the level that any of you have, nor do I have the expertise that any of you have. But I actually, as I was thinking about this episode, I was wondering, did I seek out starting to play with this stuff again because I had my ham radio license? And there are a lot of people out there who play with this stuff who may be completely ignorant that ham radio is even a thing. And so, like I said, in my case, I think my amateur radio career led me to being more interested in electronics and interested in building things and realizing that this stuff wasn't out of reach. And I'm just wondering, RF tends to be one of the black magic topics for most trained EEs. And amateur radio is definitely a gateway into understanding and unlocking the possibilities that give you. But for the hobbyist, let's talk about What does amateur radio give you that you wouldn't otherwise have?
I'd like to go ahead and start. For me, honestly, the thing that I get from ham radio the most, and not to say the most important, but probably the biggest thing that I get out of it is just something to do, an application, a project, an idea, a cause, right? So I've said it before, and I'll say it again on many different times. If you want to learn a technology or a skill or a tool, a new tool or whatever, you can't really do that in a vacuum. The best way to learn something is to say, I want to go do a thing, right? And then you say, all right, I'm going to use this thing to go learn this tool. I'm going to use this tool, this new tool that I've never used before, to go do this thing. And that tool can be knowledge. It can be a literal tool, like I've never used a table saw before, or I've never done a circuit layout. So I'm going to go download Eagle or KiCad or DipTrace or whatever, and I'm going to install it, and I'm going to read up on it, and I'm going to use it to accomplish this task that I want to do. And that task has to be something that you actually want to do, not just some exercise in a book. The exercises in the book are good for teaching a certain, teaching you how to do a particular thing, but without the context of why you want to do that thing, those lessons tend to get lost. If you go through that exercise because, okay, now I get it, now I can go apply this knowledge to this other thing that I'm trying to accomplish. That is by far, at least for me, by far the best way to learn something. And so when I want to go in and say, you know what, I want to play with some more hardware, I want to go learn some more schematics, one of the things I get out of ham radio is an application, a thing to go do. And you can get that out of just about anything. I mean, I'm also an audiophile, and I like making headphone amplifiers. It's kind of a passion of mine. I've done way more than I ever need in my own personal life, but that's okay. And so I would use that headphone amplifier as an excuse to go build a thing and go learn a tool. And yeah, I mean, for me, that's been fantastic. I mean, what are all the things that are on my workbench right now? There are things about how to get a radio mounted into my car.
So I completely agree with what you're saying, because it sort of becomes, in a way, the excuse, the kind of reason to go learn something and to motivate you to learn it. I found, too, that once you go down that path, that you'll be introduced to other things that you didn't anticipate, other topics that are relevant to that, and then eventually they come back. So I found that my interest in ham radio has led to build some industrial electronics projects that had elements of communications in it that, being a ham, helped me really understand how to make those industrial communications things work better. And it sort of kind of feeds on itself. So I think it doesn't really answer your question, Jeremy, but from my perspective, but I was sort of almost answering the other way around, which is how, does the ham radio background kind of motivate you to learn other things? Maybe the other way to look at it is if you're not a ham, what does it mean for you to get your ham license if you're not a ham? What would you be exposed to? What would you be able to do otherwise?
Yeah, because I mean, we all have the experience of having our tickets and having an interest in playing around with this other hobby, which, admittedly is a self-contained hobby. There are plenty of people out there who are buying Arduinos and doing all this stuff that have zero interest or zero exposure and maybe even zero knowledge of amateur radio. And so if you were to meet one of these people at a local maker fair, what is it that we have to offer that by joining this community, by joining with other like-minded folks who have their ticket, what does that open up for you as somebody who likes to play around in some of these other technologies and things that we've talked about in the past?
The question's real hard for me because I got started in both at exactly the same time. Right. It was the same Christmas that I got my first ARRL technician's book and I got my first Arduino. And so I ramped into both communities at the same time. And so it was, I absolutely enjoy amateur radio. I mean, obviously, since I'm on an amateur radio podcast and I have literally lost count of how many radios I own at this point. But the maker community brings a lot to the table that amateur radio hasn't, right? And you're finally now seeing the ARRL making a conscious effort to try and pull the maker sort of community and some of the facets out of that community into amateur radio to kind of help it be more relevant, which of course, seems like I have the premise that amateur radio is in some ways not relevant anymore, which I go back and forth on. But I mean, what amateur radio really brings to me as a maker, I mean, first and foremost, and I think this is the most important thing about amateur radio, it demystifies RF. Right. If you go look at any electronic circuit now, it inevitably somewhere has RF. And if you watch any of these maker YouTube videos where they do teardowns of equipment, they kind of go, and here's the RF section. We're skipping that and going over here. Right. And so being involved in amateur radio really is nice, understanding things like the bandwidth of a trace and understanding why wires have to be relatively short in some areas and can be as long as you want in others. So I think there is definitely this RF demystification in amateur radio going over to makers. And there's also much more history to it, right? Because I love reading the older documentation that amateur radio operators produced, right? Like I make it a policy that I have one handbook, ARRL handbook from each decade. I find in about 10 to 15 years, they tend to turn stuff over. And reading some of the older books, you pick up on a lot of construction techniques that kind of came into vogue and then went out of vogue again that you don't see much, right? I see almost no one except for hams do the whole dead bug style
or
and
the Manhattan. Yep.
Yeah, right. And like taking the drill bit and filing the center of it off so that you can take a drill bit and cut islands into copper clad. Like you don't see makers do that at all. Is that particular specific skill entirely useful? Well, maybe not, because perf board now is, $5 for 20 pieces. So I mean, the perf board now is very, very cheap, but those sorts of tricks, and I'm not going to include the ARRL hints and kinks books because those things were mostly more optimized for killing yourself with 120 volts than anything else. Because I'm not a fan of trying to run 120 volts through your spare piece of coax. That doesn't seem like a good hint from the ARRL. But the hints and kinks sort of stuff from amateur radio, they've got a whole century time advantage on these makers that you can pull that stuff in. Right. And so you just have to go back and read the historical and or hysterical magazines, articles and books and stuff that have come out. And so I think kind of it's an old man's hobby is certainly an arguable downside to amateur radio, but it also has its advantages once you kind of drill down to the content behind it.
What's kind of funny is when I hear you describing that, one of the themes of the maker community is the notion that if you don't open it, you don't own it. In other words, there's sort of a maker pride of understanding the internal guts of something. And to your earlier point about the RF black box, when it comes to that RF black box, the makers don't dive into it generally. So I think that one thing that ham radio does to the maker community, I'm just repeating what you just said, Kenneth, it really does demystify and open up a range of other options to the maker. So every time I see a maker project where they're doing something wirelessly, it's almost entirely Bluetooth, Wi-Fi, or maybe like a Zigbee data radio thing. And those things absolutely have their place and they're great for what they do. But you're inherently limited in range, and there's just other things you can do with ham radio that you just can't do with those ISM band or kind of public data radio techniques. So, there's sort of the obvious spectrum and power and long-range communications kind of technical capabilities that come to bear as well.
So one
one conversation I love to have with Internet of Things fans, the makers, that just blows their minds is when I really get them to finally understand the implications of APRS. And They go, oh my God, I can have free 1200 baud data with 50-mile cell sizes.
Yes. So I have this conversation with somebody who's pushing LoRa. Okay.
Yeah.
And they're going to say, oh, we've got this fantastic long range data radio system called LoRa. And the first time I heard that, I said, well, what's that? Well, it's, it's 2.4 gigahertz or maybe 900 megs. Okay, awesome. How much power do you run for such a long range radio? Oh, like 100 milliwatts, maybe. Like, well, wait a minute. Okay, physics is physics, man. 100 milliwatts at 2 gigahertz, even with a gain antenna, you're not talking like super duper long range. I mean, you in free space you'll get miles, but you're not going to get like 100 miles or 50 miles. So yeah.
Right, and then the next time I run into Travis Goodspeed, I need to sit him down and really try and figure out what they're trying to do with the LoRa Ham project.
We have I've tried to reach out to him on Twitter many times to get him on to talk about it, because we've talked about it a little bit here on the show. I mean, one of the things that I do know that's it's nice because there's a single board. I mean, there's one board that's got I think it's an Arduino. It's one board that's got an Arduino on it. It's pretty easy to get up and running. You don't have to interface with other stuff. So, okay, maybe that's, cool. It's low power. I mean, that's cool as far as low power consumption. But yeah, I would love to get Travis on to talk about LoRa Ham.
So one other thing I wanted to talk about that ham radio gets us as makers, as you, George, you were talking about how more spectrum, more power. We can do things as amateurs that you cannot do in the ISM bands. There's a flip side to that, is that you can do things in the ISM bands that you can't do on amateur radio, right?
Right.
When you use your Wi-Fi stuff, 802.11 stuff, you need to decide, I'm going to do part 97 rules or I'm going to do part 15 rules, and you make that decision up front, and then you're stuck with the rules for everything that you do, which means you can do high-powered stuff with directional antennas and do all kinds of great, awesome links, but you can't use SSH with anything other than a null cipher. Or I can do all of the, SSH or HTTPS or any of a number of other encryption standards, right? You're very limited on what you can do. So you can't really use it for any personal stuff. The applications that I would be willing to do over an amateur data link like that are severely limited. But on the flip side, if I just use my conventional, commercially available, low power part 15 Wi-Fi stuff, I can do that in SSH and HTTPS to my heart's content without having to worry about what I'm doing over that line. So there's a kind of a flip side to that. But the other thing I wanted to point out was that as I tinker in ham radio stuff and I'm learning about radios, most of my tinkering in the recent past kind of got started by looking for kits I could assemble that somebody else had made. And kind of one of the first ones I got was the U3, the Ultimate 3 kit by Hans Summers that we've talked about before, the Whisper kit. Great little kit. And I assembled it and I learned from it. And as I assemble all of these kits, I'm learning how they work, learning how they're put together. I then moved on to a bunch of QRP kits, the Pixie from eBay for like $3, the 49er, the Frog Sounds, various things like that. And then more recently, I've purchased a couple of the BitX40s modules that Farhan has been making. So I'm buying all of these kits, and as I'm doing it, and as I'm researching them and learning how they work, I am learning the material from people who know this material better than I do by looking at their works, not just reading it from a book, because honestly, that's not how I learn. I don't learn well from reading from a book. I learn by having somebody explain something to me. And I have found that staring at their design output can often be as good as having them explain something to me, as opposed to reading about the theory in a book. And so that works really well for me. And then I get to take that knowledge and apply it to other things. Excuse me. Non-radio things. For example, I mentioned I like doing headphone amplifiers. Well, they're both analog. They're both, oscillations and amplifications and filters and all that kind of stuff. So a lot of the same technique applies whether you're doing it at, 10 megahertz or 10 kilohertz, right? And so that's something that I get out of ham radio. It's just kind of a deeper understanding of electronics and theory and applications.
And I like that you mentioned those Chinese Pixie kits, and I'm going to just go on a little rant here. I've bought a couple of those like $3 or $7 Pixie 2 transceiver kits, and the one thing that I absolutely hate about them is that they are the PCBs for them are laid out on that budget 10 centimeter by 10 centimeter square, which makes the final built transceiver that you get out of those kits completely unworkable on. There's no way to work on once you build it, it's like, all right, you have now built a completely inaccessible black box because it is all so well crammed together to make it all fit in that 10 by 10. And so having built one of those, if I were to do it again, I would definitely buy the kit, because for $7 you get about $20 or $30 worth of parts, but I would treat it as a raw parts kit for making my own board, because I definitely regret having used the PCB that came with it. I mean, for beginners, I absolutely understand why you want to be able to make it, plug and solder like that. But wanting to then go in and say, well, what if I try a different audio amplifier? Whether I try a different oscillator, completely impossible on their board.
Oh yeah, I see what you're saying.
Right.
Yeah, there was an article in QST a year ago. I don't remember exactly when it was. It was not long ago, where they took a 49er kit and they modified it with a DDS. And so they replaced the local oscillator with one of the SI 5351 oscillators, and with a little Arduino and an LCD on the front panel. And it's like, cut this component out or don't populate it ahead of time, and you have to run this wire over from this inductor over there. And the bodging it was problematic. That is true.
Right. And so if someone actually went and laid out a PCB and made it available on OshPark that was like a 5-inch long, kind of exploded view of the Pixie, and the instructions for it say, buy this Pixie kit on eBay, that would be a fantastic project for someone to go crank out and do, because I think it would then be much more tractable to work on it and play around with and learn with the circuitry after you having stuffed C1 in the C1 spot and R1 in the R1 spot.
I strongly recommend that you go check out the BitX40 and buy one of the kits. The BitX40 is on a much larger board. It is laid out in a sensible way. You can literally see the groupings of components. Like, okay, this is an amplifier, and you can see that amplifier repeated like 3 or 4 times on the board, and it is, it is laid out exactly the same in each of those different sections. Like, oh, okay, I can point to that and that and that and match them up with a schematic. And here are a bunch of oblong metal cans. Those must be the crystal filter that's right there. And here is an oscillator, and it's hard to tell that it's an oscillator, but there's like a tunable capacitor and some inductors and some other transistors. It's like, okay, that looks like the LO over here. Those kinds of things. It is laid out specifically with the intent of it being hacked. He did a few things that were very intentionally. It's like, here's a connector where you would remove this one component and then be able to inject your own VFO here to tune the radio.
Wasn't it better than that? Didn't he literally put like a jumper or something that right?
You do have to remove a component, but yes.
Okay, right, and I will also second BitX40. Like the things I've been seeing people do with it and how excited that community is about building radios is something that
great radio.
You don't see that for years in the history. If I didn't live in an apartment complex with 120 units, I'd be all over it.
Yeah, Jeremy and George, I would love to either have you guys do or come on and do with you an episode on the BitX40. It is absolutely worth its own episode.
I think that's a great idea. In fact, we had talked about various build projects when we planned out the year, and one of the few commercial things we talked about was doing a BitX build, which I say build in quotes because the board's built. It's more just like wiring up the external components. But
you know what? If you're somebody who's new and trying to get into, like, I kind of want to play with doing the electronic stuff, but I don't really know what I'm doing. That is a great way to start out.
I totally agree. No, I mean, it was on the short list because we thought it was a good idea. And Farhan did such a nice job in the design. There's supposed to be a new one, by the way. I don't know much about it. There's like a micro BitX.
Yeah, the micro, yeah.
Yeah, it's going to be multi-band. I don't know. I haven't looked at the schematics or if he's even released those yet, whether he's got switched band passes or how he's managing to do that. But I'm very interested in seeing that one. I know people have talked about I'm sorry. I know people have talked about using it as a dual band by taking advantage of the existing low pass, or excuse me, there's a band pass in one of the IF stages, and if you, what is it? I think it was like 20 and 80 are both like if you have a 9 megahertz VFO. And then you take the sum of that, you can get into the 20 meter band. And if you take the difference of that, you can get into the 80 meter band. That's why 20 meters is upper sideband and 80 meters is lower sideband. So that I don't remember the exact numbers, but there was somebody I saw who modified their BitX to be a dual band without having to do any bandpass switching. It was really cool.
But if I'm just a maker guy out there, I don't even know what anything you just said means.
So right, and that's the genius part about the BitX is it kind of it comes as a usable, like the radio, the super hard RF part of it is already done, and it's a voice transceiver, not a Morris receiver, right? And so because the problem is, right, because the beginning electronics guy, the simple radios to build are the hardest ones to use because they're Morse code. And so getting the BitX 40 as this thing that is already mostly functional as an RF as an RF device, and it is a voice transceiver, and all you need to do is the fun parts. I'm going to say fun parts in a very opinion asterisk way of the very accessible parts. There we go. Accessible is a good word for it. The accessible parts of putting it in an enclosure and putting knobs on the outside of the enclosure and building the system around this RF module is a super great way to get builders into making their own radios. Because then you start, tweaking little bits of it and seeing what it does, and you start with something that is functional as an RF building block. All right, so
go ahead, George.
I just want to underscore what Kenneth was saying. I think that's a very powerful concept, which is start with something that's 80% done. You have the fun of finishing it off, but you have a very high probability of it working once you're done. And there's nothing that turns you off more than you spend a lot of time and energy on something and it doesn't work. And then you go, well, maybe this is too hard for me, or maybe it's just, this is not fun. So I think it's really important, especially in one of your first build projects, or if you're a maker looking at ham stuff, you want your first experience to be a runaway success. You don't want it to be like 40 hours and failure. I mean, that's not a recipe to motivate people.
So let me kind of pull us back a little bit to the core topic. Is HF a draw for the guy who's sitting at home building projects with Arduinos?
No.
Okay.
No, it is not.
No. Wait. Stop. Stop. So HF is a frequency range. It is not an application. When a lot of people say HF, the first thing that comes to their mind is DXing, contesting, rag chewing, that kind of stuff. And historically, that's been a lot of what happens on HF. And I agree with you. I've stated publicly before, I'm a ham radio operator and I love all the technology, but I do not like making small talk. Right? I do not like talking to people on the radio, which is kind of weird. I admit it. That I am so active as a ham and so excited to be a ham, but I don't like talking to people.
Actually, let me interrupt because I think that's really important, because if you've already got a background in electronics, like having the ability to have a conversation with another human being is probably not going to be the draw for you to want you to get your amateur radio license.
Exactly. So there is a lot of that on HF, but there's also a lot of really cool new technology happening on HF, believe it or not. Look at all the stuff that Joe Taylor has done, JT65, JT9, Whisper, all those kinds of modes. The high technology these days is what can we do with more? Joe is going the other direction. What can we do with less? And it's how little power can I use to get this successful contact? And it's all digitally controlled. You're not having to talk to anyone, but you're still using ham radio and you're still making stuff happen. I don't think it's Joe Taylor. It's somebody else who's doing the Codec 2 and FreeDV is another thing. If you do like talking to people, but you still want to do something with a little bit more technology, go check out FreeDV. It is digital voice over HF. There's some really cool stuff going on there. You were asking, is that a draw? Well, it can be. There's some cool stuff going on. APRS over 30 meters is something that I've been wanting to get into. APRS over HF, especially if I'm going to be driving long distances. I just finished listening to Kale talking to, I don't remember the gentleman's name or call sign, about WinLink, about packet in, what did I miss something?
Oh, I thought you were ramping up to just talking about APRS, and that was
no. Oh, yeah. Kale was talking to this joker about APRS. No,
yeah.
No, he was talking to somebody about WinLink today. I just listened to it today. He released it last week, I guess. And that sounds really interesting. So, I mean, I think there is interesting technology happening on the HF bands, especially with like the MF and LF stuff, the 220 meter band or 200 2000
2200.
Yeah. That's the one. 2200 and the 430 meter bands. Those we just got opened up to us. So there are some real technological challenges there. With I do not have a 10-acre lot. I can't put up a half-wave antenna on that. So whatever you do with your antenna system is going to be a compromise. How do you make that effective but still small? Right? What are the options there? So I think there's a lot that can be done on HF. Plus, HF is a heck of a lot easier to do than VHF and UHF, because your 3-inch piece of wire that connects this board to that board, you've got a local oscillator or a VFO and a mixer on separate boards, maybe because you're bodging something together, and you got a 3 to 6 inch piece of wire. On HF, who cares? That is such a tiny fraction of a wavelength that doesn't make any difference. At VHF, that is now a significant fraction of a wavelength, and you have to worry about impedance matching that wire and shielding it or making it balanced and doing twisted pair or whatever. It's going to become an antenna if you're not careful. So the things that you learn at HF, it's a much easier place to learn about the technologies and then take that knowledge and apply it to the higher frequencies where you might be more interested in working. It's like, all right, now I know how mixers and oscillators work. Let me go figure out separate, not at the same time. Let me figure out how I can apply that knowledge and what's different when I go into microwave, right, or UHF.
Let me kind of package up what you just said, because let's face some realities. You just listed a catalog of really awesome things that are happening on HF that aren't taught, that don't involve, using paddles, clicking a key, or picking up a microphone. Again, the guy at his bench at home, or gal, who is, playing with robots or building a weather station. This is somebody who is used to spending $10 to get a 1 gigahertz CPU with half a gig of RAM with wireless and Bluetooth for $10.
Yeah. And
you just explained to him how you can have these giant antennas and run at 300 baud.
Okay, so I was not trying to answer the question of what does ham radio get a typical maker. That is a valid question and not the one that I was trying to address. So what I was trying to address was, is there a draw to HF? And I think there is for non-rack Jewers. And that's really the point that I was trying to address.
And I'm just, because all of these are valid topics, but I'm going to keep pulling people back to center, because before you can have that conversation, you have to, what is the value prop of amateur radio for somebody who's not an amateur, who is making and building?
Yeah. So to go in there and start picking apart his points. First, David Rowe is the guy that does Codec 2.
Thank you.
Right, and I've been reading that since back when David was not even working on that. He was still working on the what was that? The potato, the telephone potato thing. So like it really interesting blog if you want to go back and read all of his stuff. But oh my God, has it pained me so watching him for a year and a half there, trying to figure out how to get 1200 or 1600 bits per second over a 300 baud symbol limit. Right? God. I mean, God, if there's any, like the ARRL started talking about this for a while, and I haven't heard anything in a while, but dear God, do we need to get rid of that freaking 300 baud limit, right? I mean, like RTTY is not the dominant data mode anymore. We need to go to a bandwidth limit,
ARRL is working on it. It's
right. They are right. And, oh my God. But and the other thing I'm gonna disagree with Mark on HF being easier to work on. It absolutely is if you're interested in using discrete transistors. But when you're a maker on a bench who's used to buying Raspberry Pis and is used to buying 5158 modules and all these eBay boards, a DRA 818 VHF transceiver is one castellated board that you drop on and it gives you 1 watt of VHF. Right.
That's fair. That's fair.
Wait. A DR 818?
DRA 818V, and they've got a U1. These are little castellated boards. They're about the size of a gum stick, and they're essentially, it's like an FRS radio in a board.
Wait. That sounds amazing. What's castellated?
It's where on the edge of the board, it's got essentially solder pads on the side surface. And so that way you can this is like the motherboard. You have a motherboard PCB and you take this module and drop it on it and solder on the edges of it down on there.
It looks like a postage stamp.
Yeah,
exactly.
Okay. Look, I have to ask these questions because I'm trying to look out for the 2 people that are still listening right now.
No, Jeremy, you're supposed to say, I know what that meant, but for those of you who don't.
Buddy, I try to be pretty genuine about my. Remember the time that you told me that I'm the one who asked the stupid questions?
I believe I referred to you as Plato's Simplicito. Yes,
you did. Except again, and George had said on the air publicly before we did the 3D printing episode that it was his turn to ask the stupid questions, implying that I am the one who is always asking the stupid questions.
That's right.
If I recall the conversation correctly, Mark walked himself into a corner asking if you just asked the stupid questions or if you were actually stupid.
I'm pretty sure that's how it came out. Yeah.
This isn't the method approach to hosting a podcast. I'm asking because I don't know. Castellated. So are my postage stamps castellated? Oh, we'll have to Wikipedia that later.
Only if you solder the edges of your postage stamps.
I mean, I'm actually
think of it
excited.
this way: it looks like a castle. It looks like the crenellations on a castle. Is how I always.
Crenellations. I do know what that one means.
Okay, you know what crenellations look like.
Yes, I do. I have many flashlights with crenellations.
So if you want to make an FRS handheld radio, these DRA 818, and I think they've come out with like the 828 line. I think there is a new one, and I haven't looked into it yet. They claim to be. And they're designed to run off of a lithium-ion battery, right? So their input rail is 4.2 volts, and it literally has 1 pin that is an electric microphone. It's got 2 pins that is the speaker. It's got a push-to-talk line in it, and it's got a UART that it takes like old Hayes AT modem commands to set the frequency, offset, PL tones, like volume levels, all these things. So if you take an Arduino and one of these, you can make yourself a little handheld VHF or UHF radio.
Yeah. So one thing to clarify, Jeremy, these are not data radios. These are analog FM radios. You can use them for data, but you need to do your own, what is it, like MFSK, I think is the right term?
AFSK.
AFSK, if it's slow, or if you want to go faster, MFSK or GMFSK or there's different.
Well, not really, because
some form of FSK though, because it's an FM transmitter. It will only transmit one frequency at a time. You just get to choose what frequency that is, as opposed to like a sideband where you've got this giant spectrum that you can put whatever you want in it.
Yeah, so let's clarify this for the squib. When I talk about AFSK, I'm talking about audio frequency shift keying, and this is like Bell 202 for APRS, right? Where you're making 2 discrete audio tones, right? You start talking about things like GMSK or minimum Gaussian shift keying. That part you're starting to actually directly modify the oscillator inside the radio, and you need much closer coupling to it, which is why it like 9600 baud never got anywhere near as popular as 1200 baud, because you needed a much more intimate access to the radio, which
every single radio has now.
No, they don't.
In fact, my latest ICOM ID51 doesn't even, or 5100 doesn't even have a packet port on it.
Yeah, the whole mini DIN 6 like universal audio interface thing has totally disappeared on the low end. You can only get that on the top tier mobile radios.
Well, right? But actually, even like I said, the 5100 is ICOM's highest end mobile radio. It does not have a packet port at all.
Yeah, because a lot of them are now going to like just internal USB codecs.
No,
right?
there's not. There is no way to interface packet with a 5100 except through the microphone connector. Or
that's a garbage radio that none of us needs.
Or using the D-Star stuff where you have access to the GMSK data.
Because they're trying to push it to D-Star.
But even their high-end analog 2-band radio does not have a packet port on it.
Yeah. My newest radio is a Kenwood D700, which has both a serial port for the built-in TNC and the 6-pin DIN data port for audio in and out.
Yeah, I buy Motorola gear by the pallet, so...
So you have proprietary 25-pin connectors.
No, they're 16, and I've got they're 16.
Oh, well, that's
pin.
okay then.
Well, and I've got the DigiKey part number for it, so it only costs me about $3 for the shell plus all the contacts and stuff. So, so if you want great data packet radios, like look at the Motorola Juarez series because those things are just flooding on eBay. But yeah, like the only radios below about $250 these days that have the any sort of access to the audio in them is the DR135s from I recommended this right. Alinco, yes, thank you. Yeah. Right, yeah, right. Like that's the only one. Like all the other low end stuff on the back, all they've got is a PL259 and a eighth inch jack because God, that mini DIN 6 would be so expensive on their $190 radio, But anyways, so yes, these are just audio. I've heard some bad rumors about even when you turn off the emphasis circuitry in it, so you're supposed to have more direct access to it. It is relatively filtered. So I wouldn't go as far as say that you could do arbitrary digital modes on these DRA 818 sticks, but AFSK stuff is viable if not a little bit kludgy. Making voice transceivers with them is exactly what they're designed to do, and it's apparently super fun. Right, because again, it brings you up to this system level thing where all you need to do is stick a microphone and a speaker on it. Right,
how much are these things?
Trivial. I don't remember. I couldn't tell you.
About $30.
Okay.
What? 30?
No, they're not that much. I remember. Yeah. I mean, if I were to pull a number out, I'd say something like 15 or something. I wouldn't have bought
$12.28 on eBay shipped.
Yeah.
From China.
Oh, no kidding.
Yeah.
Wow.
Right. So that being said, I've hooked a couple of them up to network spectrum analyzers, and yeah, they're not quite there on the whole,
better than the mouth thing?
Harmonics thing. And so if a lot of people playing with these things there's a great little surface mount mini circuits low pass filter that has like a cutoff at like 160 megahertz, and it's super easy because it's just like on the trace off of the side of the thing. You run it through this little. It's only like a 8 millimeter low pass filter that gives you enough attenuation at the harmonics, and I'll find that for our notes for the show. But there's several breakout boards that just have this DRA 818, headers for the serial port, and then like a low pass filter and the antenna connector, right? But it's really really friendly for VHF UHF playing around with low power stuff.
So by the way, the module is about $12, but if you want it mounted to the circuit board with the connector and some other stuff, then it's like $30, $35.
That's more reasonable. Yeah.
I just saw that, and I'm posting a link of that.
So, again, I'm the maker guy. You've just given me an inexpensive way to be able to have more power for transmitting stuff.
Yeah.
And in this case, even it's still compromised, right? There's no stack. I mean, if I'm coming from Arduino, when we had Rex on about the doorbell project, I forget, there was the Arduino library he was using, Radiohead. Maybe it has the modulation stuff in it, but these radios are basically a voice line or an analog audio line.
Mm-hmm. They're entirely analog. There's no digital aspect to this except for the AT command set you use to talk to it to tell it what frequency to be on and all that.
Right, but so yes, like if you're a maker looking for solutions, then all we can do is say on your 5 gigahertz video feeds from your drones, on your 2.4 gigahertz 802.11 stuff, you can now crank up the power, and you are absolutely hamstrung on the content that you can put through it, right? And so I think it's when you're looking from us.
That's probably a bit much, but okay.
I'm sorry. Do I have an opinion on IP traffic over amateur radio stuff?
A little.
A little bit, but and so it is a little bit like if you really do want to keep it under the scope of what are we solving for makers, it's a little bit hard. I think the right answer is what given the context that the makers are coming from, what are the sorts of things that they expect? And they expect these nice, friendly modules with relatively decent documentation, which I wouldn't say that DRA 818 really has that sort of thing. Right. And they're expecting a strong community around stuff. And amateurs definitely need to work on the friendliness of our communities to newcomers.
When I look at the ham radio community, what does it really do for makers is I think it gives them a whole huge group of people who are, many of which are very technically oriented, many of which are very hands-on in a lot of different dimensions, not just electronic savvy, but mechanically, good and interested in construction and so forth. And while there's, maybe to your point, Kenneth, there's always some, crabby old guys who are not going to be very welcoming. I've generally found it to be kind of the opposite in many ways, where it's a very welcoming environment. In fact, there is a fellow who, I don't remember who it was, but some guy did a presentation at Dayton, and he came out of like the SDR world and more from the, not really maker, almost more professional kind of high-end maker sort of thing, and was exposed to ham radio, and the hams that he knew welcomed him with open arms because they were just thrilled to have somebody under 40 who wanted to, learn something, and he was swarmed with help and has become kind of a rabid ham. And I wish I could remember the guy's name. He did a very nice presentation. Anyway, so I think there is actually a pretty amazing community of people, and I think one of the things that makers could really would value is this sort of untapped potential group of likely to be helpful people. I mean, how many hobbies do you know where there's a lot of folks whose one of their main interests is helping other people? So the whole Elmering ethos has been a core of amateur radio forever. So I think that dimension of the hobby it's maybe a little less concrete than I can do this technical specific thing, but I think that's a very powerful aspect of the amateur community.
Well, I 100% agree. I think you hit the nail on the head with the community. Community is most important in just about anything, anywhere. I think the makers have good communities, especially with internet forums and things these days. But hams have been doing this for over 100 years now, and like you said, it's kind of baked in from the very beginning with amateur radio, with the Elmers, and because in the early days there wasn't a lot of technical documentation. You figured it out by talking to somebody else who figured it out, who talked to somebody else who invented the technology. Right? I mean, it's been baked in from the very beginning for very good reasons, and thankfully, in my experience at least, it has stuck with the hobby. And I think that the makers have kind of taken that from ham radio, and not just ham radio. There are a lot of places that do this, kind of the whole Elmering and mentorship and the kind of almost apprenticeship, really. You hang out with the person who knows it better than you while you figure it out, and then you become that person for the next person, right? And I think that really is critical. And the whole thing, Jeremy, the whole premise of your question is, I think, a little bit specious, because you say, what does being a ham radio operator bring to a maker? And I put to you that I don't believe there's a difference between an amateur radio operator and a maker. I think an amateur radio operator is just a particular style of making, or maybe making is a more generalized version of what ham radio operators are, right? We are doing the same kinds of things that makers do. Some of us are appliance operators. Some of us like to get down and do things at the module level. Some of us like to go into the nitty-gritty detail and deal with individual components. These are all still making. They're all still ham radio. They're just a matter of how far down does your interest go. And so the question of what can a maker get out of doing ham radio or becoming an amateur radio operator really depends on what it is that maker is trying to do. I think the general answer is it puts more tools in your toolbox. It gives you the ability to do more things, and to gives you the opportunity to learn more technologies. If those technologies are applicable to what you are trying to accomplish as a maker, then it makes all the sense in the world. And ham radio is there. We've got Elmer's. We want to help you. We want to get you into the hobby. If you're like, I'm over here doing FPGAs to do, crypto cracking or whatever, right? That's still making, and I'm still excited to talk to you about it, but it's not something that ham radio is specifically going to be able to get you. And yes, you could come up with some contrived example of, this high-speed serial bus is actually RF and blah, 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 whatever, fine. But that's not the point. The point is that the person that is doing that non-radio related makery thing may not get a whole lot out of becoming a maker, but they might, right? And if they looked at it and they said, that kind of interests me, then they can go in and do it and get a lot out of it and maybe apply it to something else that they're doing, or they might not, right? There are a lot of things in kind of the maker community that apply to some people and not others. And I think ham radio is just one of those.
I think that's very well said, and you did a good job of kind of closing the loop on your initial thesis. When we come back from the break, I'm going to ask you another specific question about a certain set of folks out there who have gotten their amateur radio licenses. And then I want to dig a lot deeper on this community topic, because one of the things that's interesting is we talk about hams and community, and certainly around whatever you want to do, be it DXing to learning CW, to, what we are sitting here talking about, there's great community. But in the earliest days of radio, there was nothing but vitriol and competition. So we will dig into those when we come back.
This episode of The Workbench is brought to you by Autodesk Eagle PCB Design Tools. All of our projects we're doing on the Workbench use Eagle. It's great for schematic capture and board layout. You can easily generate all of the output files necessary to manufacture a circuit board. And whether you're building one board or 100 boards for your friends, use Eagle tools because they have really excellent support. They've got a great library of available components. It's widely used amongst the maker and the professional board design tool. You'll enjoy using the tools, and there's a lot of great new features. Check it out at autodesk.com/eagle, and you could download a free copy of the PCB design tool today and get started doing your project.
All right, so I'm going to throw some names at you. Jerry Ellsworth, Shannon Morse, Lemore Freed, Travis Goodspeed. I mean, these are some fairly big names in the maker community, and all of them have their amateur radio license.
Mm-hmm. Although Jerry was only recently. I was shocked that she only got it at Pacificon this year.
So why did they get that?
Because they wanted those tools in their toolbox. I mean, are you asking why does anyone become a ham?
Well, no, because everybody has different reasons. I mean, if we went around this group, everybody would have a different reason about why they became a ham.
Mm-hmm.
I was trying to prepare for the zombie apocalypse.
Well, yeah. I know that
out here in California, we call those earthquakes.
Yeah, right. But I know that many of us in the amateur radio community were leaning on Jerry for years. I mean, I'd have brunch with her, and we'd always jewel her for not having her license. And so but then again, what finally tipped her over the edge? I mean, I know that she's been playing with 160 meter magnetic loop stuff. Right.
She did that after she got her ham license, though, right?
Well, yeah, except that she had bought 4 HF rigs before it. So I don't understand what her mindset was on that. But it's.
I don't know Jerry, and it sounds like you do. So correct me if I'm wrong on this, but my understanding from Jerry is that she gets an idea in her head. Is like, you know what? I'm going to go learn how to build trucks today, or whatever it is, right? I'm going to go do a thing. And once she puts her mind to it, it just happens. It doesn't just happen. That minimizes the amount of effort she puts into it.
She makes it happen. Yeah.
She makes it happen, right? Come hell or high water, it will happen. And so I think it finally came time for her to go, you know what? Ham radio is a thing, right? And then she just dove into it head first.
Yeah, and I think that's true for many, everyone that you named there that I know. It's all kind of of course, when they decided that they wanted the amateur radio licenses, they just got it, right? And it's, why? Because those are the sorts of people that are really into being engaged and involved in all these sorts of communities and being these thought leaders in the maker spaces, and then also being involved with amateur radio. They're smart maker people. So get your amateur radio license, because that's where all the smart people are at, right?
All right, I'll take that. Well, and finally, before we wrap up, let's pull in the community thread a little bit more, because what can we as hams do? What can we do to help take our knowledge and our experience and get involved with other folks who may not even realize that you can have access to high power communication modes in many different parts in the spectrum?
Okay, well, so first I want to go back to George calling me out on being a little bit incorrect on my statement in the last segment and clarify my point that yes, the high end of the amateur radio community, not to just totally ignore your question here, but to the high end of the amateur radio community is fantastic. And kind of what I was complaining about being unwelcoming to newcomers in the community really comes down to the bottom 1% of hams are, of all the communities I'm involved with, possibly the worst, right? And makers have been grappling this with their community guidelines on open source projects and the conferences. Like everyone else is kind of grappling with it, I think, in a more effective way. And so if you were to ask me, like, what is the one thing that hams can do to make the community more welcoming to newcomers, is stop tolerating these bottom 1% guys that are really, the vast majority of the vitriol and the unwelcomingness and the condescension. Those guys just need to stop being tolerated, right? Like they've stuck around in amateur radio much longer than they tend to, I think, in other communities. And so we need to start moderating our forums. We need to start calling these guys out on it and really kind of cleaning up some of the garbage that we have collected, right? Not calling these people garbage, but kind of some of these bad habits. Bad habits is a much better term for it. Because the new user experience is absolutely pivotal in recruiting people and then retaining them. And I think is something. Go for it.
I was going to say, I'm curious where what forum are you seeing these lids? That we have a term for them in the ham radio community, and they're lids. And every community has them, right? Every community has the jerks, and everyone else is just like, shaking their heads, going, that guy is speaking again. Why? Right? I mean, go look at Reddit, go look at Twitter, and they're everywhere. Ham radio is no different. I agree with everything you said. We need to stop tolerating it. We need to stop letting it happen. But I am curious where you are seeing it happen. Are you seeing it happen on the air? Are you seeing it happen in online forums? Are you seeing it happen in person at local meetings? Right? Because each of these have a different response mechanism.
Right, and that's the thing, is it's a very much a holistic problem. I mean, I would say that I was probably very unlucky having gotten my first license in 2008. I think 2008 was a very tough time for new hams in amateur radio because we had just lost the Morse code requirement. And there was a lot of amateurs and old school clubs that were very bitter about this. And so in person at the kind of the old growth clubs, I felt a lot of unwelcomingness then. I think it has gotten better in that context, but when you look at places like Facebook has definitely made it easier for the hams to be higher profile. And so, I mean, I think the answer is all of them, right? We need to make sure, we need to clean it up in all of them. The in-person one, we need to be very careful about the inappropriate comments we make around the new people. Well, I mean, we need to be careful about the inappropriate comments in general, right? I mean, I've brought a girlfriend to the electronic swap meet, and that was the end of our relationship. She dumped me at that point because the inappropriate comments and the sexism was so inappropriate and so bad. And she's like, you associate with these people? And that was the end of our relationship, right? And so, like, amateur radio has detonated relationships for me, and I'm still here, something that says something about my character, I guess.
That's a different show.
Yes.
That is an entirely different show. Yeah.
Right. But so there is problems. But, I mean, then again, the high end is so good in amateur radio that I am still here, right? And so there's something to be said there.
There's a kind of a big middle. And the big middle are the typical guys that are not going to be obnoxious. They're not going to be. There's nothing negative, but also what often comes with that is a lack of interest or understanding, or willingness to be welcoming. And it's not for any like character trait defect. It's just, people are not always going to go out of the way to welcome the new person or to want to know what the new person wants to do. So I think one of the big risks is not the bottom few percent. I mean, they're bad in their own right and all that, but I think it's kind of the big middle. So if you're 20 years old and a college student and you go to the local ham radio club for the first time, what's your experience going to be? Is there going to be somebody who's going to welcome you there? Is there going to be anybody who's within 2 decades of your age going to be there? Are they going to talk about anything that you're interested in? And I don't, I don't know. I mean, a lot of times I think the answer is probably not. And I think that amateur clubs and groups have to be much more open and interested in attracting new hams. They don't have to be young. I mean, but new hams into the fold, and not try to force them to be the way they are, but also try to understand, like, why are you here? And maybe they're there to be like the other people, or maybe they're there because what interested them was, I read an article about high altitude ballooning, and they used ham radio to telemeter the data. And I'd love to do ballooning. I give you a specific example. A good friend of mine, Jason, who's in our radio club, he got his ticket about 3 years ago because he's building drones that he's flying, and he's flying them with first-person video streaming feed. And there is something about being able to do that with a ham ticket that lets you run more power. And so he got his license only because he was interested in RC aircraft flying. Well, it turns out once he figured out what ham radio was about, and we were a pretty welcoming club, and he kind of shifted gears to make ham radio his primary hobby for the next 3 years. So he kind of went hook, line, and sinker down the ham path. But that's because, we encouraged that. And we were very interested, like, well, what do you do with a drone? How do you fly it? What are you going to do with ham radio with your drone? We were all very interested. And so it became a nice situation where he was teaching us something while we're teaching him something. And that was great. So
he actually blamed me a bit for that, because I first met him at Burning Man. And,
oh, no kidding.
Yeah. And so we're like, yeah, if you we're on this, simplex frequency, because this was me with another Cal Poly amateur radio guy. And so we had our standard Cal Poly simplex frequency. We're like, yeah, we'll be on this frequency. And so we got him so much into voice that he was lamenting years later. He's like, God, you guys got me to radio, and I bought like a mobile rig, and I sold all my drones. Now I've got no drones left. So yeah, I actually played the other side hilarious. Of that story. Yeah.
Oh, that's great. By the way, he's back into building a drone again. He just sold one of his radios. So yeah, the pendulum does swing.
Yes. But it's a small world in the Bay Area. Everyone should come to the Silicon Valley.
Yeah, that's pretty,
Jeremy.
That's pretty clear. Again, if it weren't for the fact that I like my money, plenty of access to fresh water, and freedom, I'd be there in a heartbeat.
Yeah, not wrong.
We got rain this year.
I heard you guys were allowed to have more than 2 glasses of water a day. That's good. That's good.
That's right. All my coworkers from Dublin, I was like, do we have to bring bottled water with us? This is Dublin, Ireland, by the way.
Why, mate? They have Guinness. So we've kind of been all over the place, but to kind of sum up and take final thoughts, the real key is that the person who is a maker winding up in amateur radio is generally going to be one of 2 reasons. Either they're trying to solve for a specific problem, and they believe that somewhere in this hobby, and again, this is a hobby of hobbies, right? I mean, George, I have a lot of hobbies, and my hobbies aren't as varied as what is, within amateur radio.
I have precisely one hobby. My hobby is to collect hobbies.
Outstanding. Yes. So they come here looking for an answer to a specific problem, or to add a specific tool to their capabilities. Or they come here because it's just there to do, and they are going to do it, and that's just all there is to it. So there's that. But that at the end of the day, the thing that is probably most important, at least we've spent a lot of time talking about, is having a community like what we have here, like here tonight. I mean, the folks that, our listeners, a lot of the folks who are sharing online and contributing to community, whether they're writing code or publishing designs or getting together to just share knowledge, are really the things that will help those people be the most successful that they can be as they try to make it this, journey or transition into amateur radio. So let me go around. Mark, final thoughts.
Final thoughts on makerism and ham radio. There are a lot of appliance operators out there, and I'm not going to trash talk appliance operators, people who just want to buy the radio and use it and the project is using the tool. The project is not the tool itself. And that's totally fine. I'm that way in a lot of ways. That's why I bought a pre-made 3D printer. That's why I bought, I haven't dove down to the path of CNC milling and making my own tools in that regard. But if getting into learning how your radio works is something that interests you, I highly encourage you to do it. Right now, my recommendation for an entry point into that is a BIT X40. There are lots of different ways of doing it, but I think it is a very rewarding path for anyone, and I think it is more doable now with the low cost of available parts and components and modules and nearly built things, and the communities that are built around these pieces online. The BIT X40 community is amazing. Is it okay to mention a different podcast, I presume?
Of course.
Okay, Solder Smoke. I absolutely have been really loving Solder Smoke lately because they've been getting into the nitty-gritty details and the actual, underlying electronics of what's going on in the different radios. And I'm really glad I found them. I only found them recently, and I've been really enjoying that podcast. But it's a great way to get in and learn what's going on inside your appliance. It's not for everyone, and I'm not going to trash talk you if it's not for you. But if it is for you, I strongly encourage you to do it. It can be done. These things are not that complex. The simple radios are really amazingly easy to understand once they've been explained to you appropriately. And I have been starting down this path just in the last few years, and I am not looking back. I've been having such a great time with it. I'm learning so much about it. And I would love for other people to come along with me on this path. So to that end, hit me up on Twitter, Smitty Halibut, SmittyHalibut. And let's start some conversations. And I just love to hear what's going on with you guys, what you're thinking about, what kinds of projects you're working on, all that kind of stuff. Hearing what you're doing energizes me. So please reach out to me and let's build that community.
Yeah, I plus 10 on that one. Kenneth, final thoughts?
I really think that the important thing that every hobby can bring to the table is having a positive and welcoming community. And I think the trap that amateur radio falls into is, and I think this has improved a little bit, but we always need to remind ourselves that there isn't any criteria that makes a true amateur radio operator. There is the Morse code guys, there is the homebrew guys, there is the appliance operator guys, there is the MCOM guys. All of it is still doing amateur radio right.
Absolutely.
And it is such a multifaceted hobby that there are people that are working on parts of this hobby that you don't even know exist. And that's something that we just need to stop thinking about, is who is in the right and who is in the wrong here. I mean, people can debate Part 97 interpretations all day, and I fall in that trap. But when it comes to which parts of the hobby really follow the spirit of it, in like the 5 objectives that the FCC lays out for what amateur radio is supposed to accomplish, I haven't heard any parts of it that don't fall into those categories. So, we definitely need to always be welcoming of what other people want to do with it. We want to empower them to join us in what we're doing it, but also look at what others are doing and what you could get out of them. Right. And this is what crosses over between amateur radio and makers, is we can both learn an unbelievable amount from the others. And so it's all about cross-pollinating and sharing ideas and be kind to each other. And I'm on Twitter. I'm KWF, and I'm on there all the time. My longer form stuff is blog.thelifeofkenneth.com, which I post at very, very rarely. But that's because I have a real job now. And don't send me your project. Send them to Smitty, and then just mention me, because I couldn't deal with that many mentions.
I can. I want to hear them all.
Yeah, do it.
All right, George.
Well, first thing I want to say is I'm really grateful to hang in a community with guys like you. I mean, I mean that very sincerely, that this has really been a lot of fun. And I hope we could do this some more. This has really been great. And I could imagine, I made some notes here. There's probably 8 or 9 topics that we could come back and do shows on and really dig deep. And I think one thing that is exciting to me is that when I look at the ham radio world, there is this big spectrum of interest and a big spectrum of knowledge and expertise, and spending time with people who you can learn from and share your ideas with is really a load of fun. And I think this is sort of a theme that carries into this community concept. I think if you couple ham radio with the maker community, then you have just an even bigger group of people who really love to learn and love to build stuff and love to share their passion for what they do. So I think there's a lot of synergy there. The technical details might be a little bit different, but that's what is really quite interesting. So I guess my final thought, Jeremy, on the specific topic is I think for the future, I would encourage our listeners to learn more about the kinds of things that are happening in the maker world. So whether it's raspberries or Arduinos or communications in the digital domain, bring that stuff into the ham radio world, because that's what the future is going to be like. And likewise, I think people who are inclined to be makers are exactly the kind of people who would have naturally been ham radio operators 30, 40 years ago, before there was any other kinds of super technical kind of hobbies. So I think the same kind of people. And a lot of those people may really enjoy our hobby of ham radio. So I think it's a very good mix. It's a very good match between those two communities.
Well,
so
I'll add to that one little thing is that please do come join so that you can help us fight things like 300 baud limits.
Oh, gosh, yes.
Yes, please.
FCC, if anyone from the FCC is listening, for the love of God and all that is holy, please fix this.
Well, I want to thank everybody for coming together, and Kenneth and Mark especially. I think it's been a nice treat to have you guys on, and unfortunately for you guys, we will love to have you back and expect to have you back for topics in the future.
Tell me how that's unfortunate.
Well, because you're coming whether you want to or not. I mean, that's just how
I'm
it's
in.
going.
Sold.
All right. Well, thanks everybody for spending your time with us tonight. Again, we'll do a quick round real quick of how to get a hold of everybody. My name is Jeremy. I am KF7IJZ. You can follow me on Twitter at KF7IJZ. The only reason I say Z is because on a repeater, Z and C sound an awful lot alike. So therefore, I say Z. You can also email me at workbench@hamradio360.com. That actually goes to me and George. If you have any questions, feedback, topic, show ideas, an interesting project, we love to hear from our listeners, and we pretty much read everything that comes in, even if we don't have time to respond to everything.
And I'm George, KJ6VU. You could reach me on Twitter at KJ6VU or by email, george@hamradio360.com.
Kenneth Finnegan, W6KWF. You can find me on Twitter at KWF, and it's probably the best way to get a hold of me. You can find me online on blog.thelifeofkenneth.com. I'm on YouTube. Just search for Kenneth Finnegan. And my email address is kennethfinnegan2007@gmail.com.
I'm Mark Smith, KR6ZY, crazy with a 6 in the middle. Probably the best way to get a hold of me is on Twitter. I am Smitty Halibut, SmittyHalibut, just like the fish. But I also have a YouTube channel. Do a search for Smitty Halibut there, where I live stream working on electronic circuits. So if you're curious about some of the projects I've mentioned on this podcast, you might be able to go and see a video stream of me having actually worked on that project.
I liked watching you design clocks. All right. Thanks again, everyone, for listening. As always, 73. Next week, we will be back with the flagship Ham Radio 360 show, and the Workbench will be back the week after that. So we'll talk to you all in 2 weeks. 73.
It was great to meet you. What in the hell?
It all sounds great after post.
Oh, geez, it does, doesn't it?
So this week we thought we would. No.
Yeah,
you're
go
gonna
for
edit. No. I'm going to, but you're gonna edit this out. So this week we have Mark and Kenneth on with us because our topic is going to be if you are somebody. No, let me start over. Okay.
Ooh,
That's what we call a hook.
man.
You know, actually, what's sad? We're actually ahead of schedule from where George and I usually are at this point in the middle of the night.
At this point, Jeremy says, "Where's that pizza?"
Yeah. Well, no, you're the one who's usually hungry because I'm usually making you record before you've had dinner.
Well, that's true.
Yeah. I rob you of food and you rob me of sleep.
Yeah,
All right. I have to go let the dog out. I will be back.
that's a euphemism for what?
Oh, so now we know. Can we go call the people who made that song and let them know so they can stop singing that damn song? Jeremy is who let the dogs out.
Finally. All right. I'm going to go take a bio break too. At work, and his work's firewall was. Hello, Jeremy.
Is that a gazinta or gazetta? I got to know.
Did you bring your Skype into the bathroom with you?
Oh, no. That was me. That was the sound of the T.
I
Sure.
repeat my question.
I don't know what those terms mean.
Goes into or comes out of?
Oh, I get it now. I thought those were like Greek words.
Let's see if I can do this one. Beep, 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 beep. Anyone get that reference?
Is that the Russian woodpecker? No. But the
No, it's WWV, but it's the data encoding. They have a very low frequency tone in their audio signal that if it is 1/3 of a second long, it is a 0. If it's 2/3 of a second long, it's a 1. So we are recording now, but this is not going to make it into the show.
No. George will edit all this out. And actually, to George's credit, there have been times because like I used to try to like keep markers where we would have guffaws and do all this shit. And to George's credit, he has never let something through.